Hey everyone, a very warm welcome back to the channel. Today we have another very amazing question from the chapter of matrices and determinants. The question is saying if sum of elements in each row of the matrix A is equal to 1 and sum of elements in each row of the matrix B is equal to 4, and similarly sum of elements in each row of the matrix C is equal to 5, and if we define D is equal to A power 6 into B power 4 into C power 9, then we have to find the set of all possible values that S can take, where S is equal to sum of all the elements of the matrix D if orders of A, B, C are 4 by 4. Maximum time allotted would be 15 minutes. Ideally, you should try to do it within 6 minutes. So you can pause the video, give the question a try, and then make sure to return back to have a look at the correct solution. So I hope all of you have tried. Now the answer to this question would be 4 power 5 into 5 power 9. So this is the only value that S can take. So S is a constant, okay? And its value is equal to this. Now the concepts and formulas used are very simple and basic. Simply the definition of matrix multiplication we should be aware of, and that's all that is being used in this question. So if C is equal to AB, then Cij is defined as summation Aik into Bkj, k is equal to 1 to n. Of course, the orders of A, B, and C also we should be able to figure out. It's very direct and easy. Now we are going to develop a lemma using which we are going to solve the problem. So we are basically defining P matrix as we are basically taking two matrices, two square matrices, P and Q of order n, and we have assumed that the sum of elements in each row of P is lambda and sum of elements in each row of the matrix Q is mu. Both mu and lambda are assumed to be constants, right? Now, if we define the product matrix of these two, R is equal to P into Q, then R's sum of elements in each row will also be a constant, and that constant value would be equal to lambda into mu. Now let us see how to prove this. So we have Rij obviously equal to summation Pik Q Kj, k equal to 1 to n by definition of multiplication, and the sum of elements in ith row of R, which we can call as alpha, let's say. So alpha would be equal to what? Summation Rij, where now look, the things to understand here is ith row, when we are saying I can vary from 1 to n, of course, because either you can take first row of R, or you can take second row, third row, fourth row till nth row, right? So any row you can take, and its sum of elements we are trying to find. Now, why does this represent sum of elements in ith row? Because if you expand this particular summation, if you open up, then you will get Ri1 plus Ri2 plus Ri3 plus till Rin. This is precisely the sum of elements that are present in the ith row, because this element is ith is in ith row first column, ith row second column, ith row nth column. So clearly all of the elements in the ith row have been summed up. So now what I'm doing is Rij value I will substitute from here. So it becomes equal to this sum, right? I have just substituted the value of Rij. Now I will switch these sums. The reason we can switch is because 1 and n are constants, 1 and n are constants. So whenever they are constants, the order of summations, sigmas, we can change. So that's exactly what we have done. Now clearly Pik is independent of j, right? So this can be taken outside the summation in multiplication because it does not depend on j. So this is what it becomes. Only qkj remains inside this particular sum. This comes out as a multiplication outside the sum in which j is the index. Now, what does this represent? Summation of qkj. Obviously, it represents the sum of elements in kth row of the matrix Q. Because if you expand this, it becomes qk1 plus qk2 plus qk3 till qkn. Obviously, this is the sum of all elements in kth row of the matrix Q. But that is given to be a constant as per our assumption in the lemma. So that is the constant mu. Basically, any row you take of Q, the sum of its elements is assumed to be mu. So that's what we have written. So this I can now replace by mu here. So alpha is equal to summation Pik into mu, right? Now mu comes outside because it is a constant. So outside the summation it comes. But obviously, what does this represent? It represents sum of elements in ith row of the matrix P. But that has also been assumed to be constant, which is lambda. So alpha becomes nothing but a constant, which is equal to mu into lambda. And this basically completes the proof, of course, because that's what we had started or set out to prove. Now, since we are given d is equal to a power 6 into b power 4 into c power 9, using the lemma, sum of elements in each row of d will also be a constant, which is equal to 1 power 6 into 4 power 4 into 5 power 9. So basically what we have done is, you can write d as a into a into a into 6 times, then b into b into b into b into 4 times, then c into c into 9 times, right? But since we have just proved in the lemma that if these matrices are such that their sum of elements in each row is constant, then the product will also have uh, sum of elements in each row as constant, and that constant value is simply equal to lambda into mu, which means the product of the individual sums of the rows of each matrix, right? So since for A we are given that constant is equal to 1, sum of elements in each row of A is 1, right? So it will be 1 into 1 into 1 into 1 into 1 6 times, so 1 power 6 into 4 into 4 into 4 4 times, so 4 power 4 into 5 into 5 into 5 9 times, so 5 power 9. Okay, so using that lemma we have been able to write that sum of elements in each row of D would be equal to this. But obviously the order of D would be 4 by 4, because ABC all of them have orders 4 by 4. So it will clearly have 4 rows, but sum of elements in each row in D is this quantity. So look, what we are saying is there are 4 rows, right? 1 2 3 and 4. So if we want to find the sum of all elements in D, what would that be? This plus 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 this. So all the elements we have to sum up, right? But I can also say it like this: sum of these elements plus sum of these elements plus sum of these elements plus sum of these elements. So basically sum of all elements in a row plus sum of all elements in another row, and similarly for all the rows. But all these are constants. Sum of elements in this row is also this quantity, this particular quantity. Sum of elements in this row is again this quantity. So basically it will become 4 times this quantity, which will give us the final answer as 4 power 5 into 5 power 9, which basically represents the sum of all the elements of matrix D. So I hope you all were able to follow through the explanation and got the final answer. Make sure you like the video, comment down below what you like the most, and subscribe to the channel, share it with the friends, hit the bell icon to never miss an update, and I'll see you all in the next one.